Welcome, this is Chuck Ridgway, Automation Technology Manager here at Horner. Today we think we've got a good program for you. Now for some of you, you may think that today's program sounds a little blasé, maybe something you've heard all before, but no, that we've got some new things for you today. Yes, we're talking about compare functions, and yes, that does include kind of the run-of-the-mill, less than, greater than, equal to. What could be exciting about that? Well, there's some other instructions that fit under compare functions that a lot of people forget about, including our own Casey Gardner, which we'll talk about in a minute, including limit functions and time and date scheduling functions. So let me bring in Mr. Casey Gardner. How we doing today, Casey?
Hey, not bad. How's it going, Chuck?
Going great. Hey, before the show we were talking about, we're just doing compare functions today, but I mentioned the time and date functions and you said, geez, I forgot all about those. So I guess those are some instructions that you haven't used that frequently either, have you?
No, not really. I skipped to the already knowing system registers where time and date are held and just do a bunch of compares instead of just one, which is pretty much a little bit extra waste of time. So yeah, even I've got something out of today's message.
Absolutely. Okay, so the rest of you should definitely pay attention then if Casey's going to get something out of today's program for sure. So Casey will be manning the chat. If you have any questions, chat those in. He'll get them answered, or he might save them for the end. Also, if you're watching this on replay, we still want your questions. We'd love your questions. Just go ahead and type them in the comment section, and we'll answer those as quickly as we can. Okay, let's go ahead and get started. Okay, let's take a look at our program for today. So yes, we're talking about compare functions, and that does start with the traditional compare functions such as the less than, greater than, etc. But we've also got some other instructions that many of you are not as familiar with, including the limit function, which is great for determining if processes are in alarm or running normally, and also the aforementioned time and date compare functions. If you're doing any scheduling at all with your machine, you're going to really love these function blocks. They can really save a lot of work and they can make things really slick. You can end up with some really slick scheduling in the end by using and taking advantage of these time and date compare functions. Of course, we're going to give a nice application example or multiple application examples and a detailed demonstration as well. So let's go ahead and dive right in. Okay, of course, let's get started with standard run-of-the-mill compare functions. Compare functions in Cscape, just like any other ladder editor, provide the ability to be able to compare the values of multiple variables or a variable against a constant. Okay, and these are the traditional compare functions of equal, not equal, less than, greater than, etc. But in addition to this particular function under the compare group in the project toolbox, you've got the limit function. We'll cover that as well. Okay, traditional compare functions. We start with two inputs to the function block, and we have two variables that can be compared against each other, or you could compare one variable against a constant. Of course, they're going to pass power if they're true. Now, one programming hint that many of you may not be aware of is the fact that let's say that you're in the middle of programming your program and you've inserted a greater than instruction in your program, and in the troubleshooting process you realize this needs to be a greater than or equal to instruction. Well, you don't have to delete that and put a new instruction in. You can simply right click on the existing compare function and then change to a different compare without doing any reprogramming, without entering in the variables again. So that's pretty darn convenient. So don't forget about that little tip if you are in the process of troubleshooting and you realize that you need, let's say, less than instead of greater than, for instance. Okay, now, while I'm sure just about everybody is familiar with the traditional compare functions, not as many people are familiar with the limit function that's also included in Cscape. So with the limit function, instead of just having two inputs for comparison purposes, you have three. So you have the variable that's going to be compared, and then you have a low input and a high input. Now, if the variable is between the low and the high, then the function block passes power flow. So this is really useful for determining, for instance, if a process is running normally. So if you've established a low limit and an upper limit, and the current variable is right in between there, the function block passes power flow, and you know the system's running normally. So that's pretty convenient. Let's take a quick look at the limit function with some real numbers. So let's say that on the low input of the limit function, we have a value of 25. On the high input, a value of 75. Now, let's say our variable is 15. Well, our variable is below the low input, so we're not going to pass power flow, so effectively the function is false. If our value of our variable is 50, we're right in between there. We pass power flow, the function block is true. If the value is 80, we're above the high limit, therefore we're outside the range, the function block is false. So as you can see, that is tremendously useful for determining if a process is running in a normal condition. So using the variable with a low and a high limit. But let's say, for example, that you're trying to determine if a value is outside of those limits because you want to detect an alarm condition. Well, you can still use the limit function, but this time just reverse your low and high inputs. In other words, the upper limit, put it as the low input. The lower limit, put it as the high input. And then when you do your variable comparison, if the value is not between those two limits, then the function block passes power flow. So once again, most useful for detecting an abnormal condition or an alarm condition, for instance. Let's take a look at some real values. Same example. This time though, my low input is 75, my high input is 25. Okay, so you see that we pass power flow for the values of 15 and 80, all right, which effectively are alarm conditions. And then we don't pass power flow for a value of 50, which is a normal condition. So again, a little slightly different use of the limit function, allowing you to nice and easily detect an abnormal condition or an alarm condition. All right, now we're going to get into those functions that Casey had forgotten all about, and those are a group of instructions that we call our time and date compare functions. They're sometimes referred in the help file as scheduler type functions because they're so useful when you are trying to detect or trying to schedule something to occur on certain days of the week, only on weekends, certain times of the day, certain days of the month, those sorts of things. Now, as Casey mentioned, you can always use traditional compare function blocks and take advantage of the system registers that contain all the real-time clock information. You see those listed there on the right. However, if you do take advantage of these time and date compare functions, in many cases you get some extra functionality or some faster implementation than you'd get just by using traditional compare function blocks and having to use multiple compares in series or parallel and those sorts of things. All right, so let's start with one of the most useful time and date compare functions, and that is the time of day compare. So this is a function block that passes power flow if the current time of day from the OCS real-time clock falls in between a start and an end point that are entered into the function block as either variables or constants. So if the current time of day is in between the start time and the end time, then this function block is going to pass power flow, and all the inputs are integers. Now you'll notice that the inputs for start and end time are individual integers, one for hour and the other for minute, for each of the start and the end time. Okay, so that's how those variables are handled, as integers with a separate integer for hour and a separate integer for minute. Next, let's take a look at day of week compares. Now, with the time of day type compares that we just talked about, almost certainly you're going to assign variables as the input to the function block as opposed to hard coding a particular time. So for instance, on that last slide, if we were in the process of trying to have something happen during first shift and we wanted to have some logic that basically detects is it currently first shift or not, we could hard code in the starting times and the ending times for first shift. However, if first shift changes in a few months or a few years, we have to get Cscape out to make that change. So it makes a lot more sense to assign a variable to the time of day type compare function. For the day of the week compare, it might make sense just to hard code it in, because most of the time, if you want something that occurs during the work week Monday through Friday is pretty much the work week. Now, that's not universally true, though. In some countries, their work week is Sunday through Thursday. So if that's the scenario, then maybe you would want to assign a variable to the day of week compare instead of hard coding it in. Now, if you do decide to use a variable, the way that works is the input is a single integer where each day of the week is bit mapped to a particular bit, with Sunday starting at the least significant bit and then moving up the days of the week all the way through bit 7. Remember, we're a 1-based programming language with Cscape. Okay, so as you can see on the example I have there, if you have bits 2 through 6 set, which happens to work out to a decimal value of 62, then effectively that's trying to detect or include the work days, or the Monday through Friday days of the week, where Sunday and Saturday are set at 0. Okay, so you're going to pass power flow on a Monday through Friday type scenario. So if you use a variable, you're going to need to code it like that with that single integer. If you're just hard coding it in, you can obviously select the radio button for each day of the week that applies. So that is the day of week compare. Next, let's take a look at the day of month compare. Now, this is very similar to the last one we talked about, except instead of it being a single integer for a variable that's the input to the function block, it's a double integer. So let's say you have something that occurs on a machine twice a month, and it's always on the 15th and the 31st, or the 15th and the 28th, whatever the case may be. Well, you can effectively take a double integer, and again, with the least significant bit being the first day of the month, and the 31st bit of that 32-bit double integer being the last day of the month, at least for 31-day months, then you can place your ones for the days that you want to have power flow passed on the function. Okay? So in this particular case, if we want the 15th and the 31st to pass power flow and effectively detect that, yep, it's the 15th or it's the 31st, then effectively we're going to set those 2 bits to get the value that we want for that case. Okay, so that's the day of month compare. And I'm going to show you examples of all these of how you might use them. Next, we've got the month of year compare. Very similar to the last two, except again, you've got 12 months in the year. It all can fit easily within a single integer. So January is bit 1 all the way up through December, which is bit 12. And of course, the top 4 bits are going to be all zeros. All right, so if you want something to occur only June, July, and August, then you can set the June, July, and August bits to 1s, and then use this function to compare the current time and date in the calendar clock with those 3 months. If it is June, July, or August, then it'll pass power flow. So those are the month of year compares. Now, I will admit, this next function block I've never used. This is the year compare. So in theory, you could set up some logic that says, hey, if it's between 2022 and 2027, then I want to pass power flow because I wanted to detect that we're in one of those years. I'm struggling to figure out an application for that, but we've got it there just in case. So I won't have an example of how to use that today, but it's a pretty straightforward function block. In this case, there's no bit-mapped integers or double integers. Literally, you have a start year and an end year, and that's pretty much it. And again, if you're talking about utilizing this, then your start year and end year would be consecutive integers. Okay, so if you're talking about, let's say you're talking about variable-based ladder, then you're going to want to set up a variable that is integer-based but has a dimension of 2, so that the first 16 bits, or the variable sub 0 is your year, and the variable sub 1 is your end year. So start year would be sub 0, end year would be sub 1. If you're talking about register-based logic, and let's say you assigned R1 as your start year, then R1 would be the start year and R2 would be the end year. Again, all depends on if you're using variable-based logic or whether you're using register-based logic. Okay, next let's talk about applications where you can use these time and date compares, because there's plenty of them. Lighting control is a big one, right? Because one of the big parts of lighting control is turning the lights on and off at certain times of the day. Yes, of course, you might want to adjust the intensity of the lights. You might want to change, for some of our really high-tech grow lights, you might want to change kind of the makeup of the light in terms of its color. Same thing for some of our inspection lights, where maybe you have different colored cars that you're inspecting and you've got RGB inspection lights and you want to change the color to make the car appear brown, for instance, so you can pick out defects easier. There's lots of things you do with lighting control beyond just turning lights on and off at certain times, but that's a big part of it, right? Also, production monitoring. In a lot of cases, we want to get data out of our machines. How efficiently are we using those machines? How efficiently are we doing production? How's our quality? So we can bake a lot of that stuff into OCS products, whether they're controlling the machine or whether they're being used as strictly an OEE type product bolted on the side of an existing machine that's got a previous controller. So those are all applications where scheduling is pretty important. Also, preventative maintenance. So you may want to set flags so that for certain days of the year or days of the month or whatever the case may be, you may want to flag the maintenance department that, hey, you should really take a look at changing this filter or adjusting the oil pressure, whatever the case may be on a preventative basis. Using scheduling functions can be useful for that. Okay, now it's time for us to do our demo. We're going to demo first kind of traditional compare functions and limit functions. So let's go ahead and fire up Cscape. Okay, so here's an application I've got, and I'm going to go ahead and bring in our OCS here. Let me go ahead and go back to the main menu. Let's say that we've got an OCS and we've got a couple areas of scheduling that we're going to be doing in this application. Let's say one area of scheduling we're going to be doing is preventative maintenance, trying to flag the maintenance team when there are certain maintenance tasks that need to be performed. Okay, and another area of scheduling is going to be facility lighting control, scheduling when lights are going on and off, which days are holidays, which days are weekends and weekdays, all those sorts of good things. Let's say that's the sort of scheduling we're going to do in this particular application. So let's go ahead and get started with the preventative maintenance type scheduling that we might do. For instance, let's take a look at some traditional compare functions. So if we take a look here at this logic here, what we're doing is we're trying to look and see, just using traditional compare functions, if today is a day based on a preventative maintenance schedule that we need to change the filter. So if we take a look at our OCS, okay, we can see on this OCS screen here that we've got a couple days in which we can configure a filter change. So let's say that we want it to be changed on the 14th and the 28th of every month. Okay. All right. Well, looks like I made a programming error here. I've got day one. I've got the same day being configured for both days. Not a big deal. Just a Chuck Ridgway programming error. But basically, we can configure the day of the month that we want to change our filter. So the way I've got this programmed here, every month on the 28th, we need to set a flag that says we're going to change the filter. Okay. So let's take a look at how we would program that logic. Now, normally what we would do, and let's just go ahead and fix it while we're here, for crying out loud. There's no sense doing a demo with an error in it. So I'm going to go to the screen that has these two variables here. Change day 1. Okay, this is an integer that represents the day of the month that I want to change the filter. And we're going to do this every couple of weeks. So change day 2 is the other day that I want to change the filter. So I need to assign the proper variable to that and not copy and paste and forget to do the variable change. All right, very good. All right. Okay, so we've got 2 different days in which we can potentially get a light to turn on that tells us, all right, it's time to change the filter. All right, let's take a look at that logic here. So using traditional compare blocks, we need 2 of them, more or less in parallel. So we need to check to see if the current time and date is equal to the first change day. We also need to check and see if the current time and date is equal to the second change day. And if either one of those is true, then we're going to turn on a pilot light maybe even send an email to the maintenance supervisor saying, hey, today you need to change the filter on machine 3, air filter, whatever the case may be. And then if neither one of those days are the case, in other words, if today is not change day 2 or change day 1, then we clear our filter flag. And I've got an error here too. How about that? So this should also be filter 1. There we go. All right, so that's where copy and paste errors can do for you sometimes. So again, we're checking to see, is today's date compared against the current date from the real-time clock, is it equal to the first day we've selected as our change date, or the second day we've selected as our change date, or neither of the days we've selected as our change date. Okay, so that's just using traditional compare blocks to do this sort of scheduling. All right. Next, let's go take a look at something else. Let's go take a look at using what's called a limit function. And that is shown over there in the next few rungs on the bottom here. And it's also shown on the right-hand part of the screen for our HMI screen there. Okay, so what we have is effectively we have set a low limit and a high limit for our differential air pressure. And if the differential air pressure falls in between low and high, then air pressure is normal. If it falls outside of that, the normal coil will not be turned on because we won't be passing power flow. So this is using the limit function in kind of a traditional approach. Now this function block, we've reversed the high and the low input. All right, so our high level is set for our low input and our low level is set for our high input. What does that do? Well, remember what we just talked about a few minutes ago. That basically means that if this variable falls at low or below, or at high or above, then we're going to pass power flow. So we're sensing, in this case, for an alarm condition. So if we take a look at our current air pressure, okay, which is 0.7 inches of water, then you can see that we're in the normal range. If we were to change our high alarm level to say 0.6 instead of 0.8, you can see that now we're in alarm because we're no longer in between those limits for normal and we are outside those limits for the alarm condition. Okay, so that's the limit instruction. Can be pretty useful for determining conditions are normal or determining conditions are abnormal or in alarm. Next, we're going to take a look at time and date compare function, examples of how to use those. All right, so let's go back to Cscape and we'll go ahead and we'll turn on our OCS. We'll go back to the main page, and this time let's go to our facility lighting page. Okay, so I'm going to switch to a different section of my ladder. This is my lighting control. All right, and what we're going to do here is we're going to start with logic that detects, is it a weekday or a weekend? And based on whether it's a weekday or a weekend, we're going to set a different schedule for turning the lights on and off. So let's start on our HMI screen and see what we can adjust there. Okay, so first we're going to take a look at our start and stop times. So on this screen, I've established the start and stop times for my weekday lighting control, my weekend lighting control, and my holiday lighting control. And it just so happens that my weekend and holiday lighting control is set for the same start times and stop times. Now, what I've used here, and I'll show this to you in Cscape here, what I've used here, and we'll navigate to that screen. What I've used here, these are time objects. Okay, so this is a special time object where you point at a variable and you can then use this block to display the current time, display a time set point, to change a time set point, whatever the case may be. Now, this particular function block, the way it works is you assign a variable to the function block, and then it uses 3 consecutive words. Okay, and those 3 consecutive words, if you're talking about time, are seconds, minutes, and then hours. So the first word is seconds, the second word is minutes, and the third word is hours. So what I'm looking at here is my weekday start time variable, which you'll notice has a dimension. It's an integer type variable with a dimension of 3. So that is the variable assigned to this particular time data object. Okay? And then I've selected hour and then minute as my display format. I've also, double-clicking again here, made it editable. So I can go ahead and, from the touchscreen, I can go ahead and change this time set point if I want. Okay, and if I do that now, you can see I can change my time set point, for instance, from 6:12 maybe to 6:06. Okay? All right, so I have an editable time set point, effectively, by using a time and date data window, or data object. And I didn't point it at the real-time clock to display the current time and date. Instead, I pointed it at a variable that was integer-based with a dimension of 3. All right, so that is the object I've used on the HMI screen to display my start and end times for the weekday, the weekend, and the holiday. Now let's go back to our ladder logic here and take a look at how that applies. Okay, and what I'm basically looking at, if we're talking about weekdays, I'm basically looking at this function block here, whose start hour and start minute point at that data object that I just showed you. Okay, remember, the first word is seconds, and I'm not involving seconds at all in this time of day function block. I'm only involving minutes and hours. So I'm pointing at the hours word for that variable first, then I'm pointing at the minutes for that variable. So that's the start time. My end time, same thing, but it's now the end set point. Okay? All right, so that's how I can use a time of day compare block to see if my current time falls between the start times and end times for the particular event that I'm looking at. In this case, my weekday lighting control times. Now, in series with this time of day function, I've also got this day of the week compare function. All right. Now, in this case, I did not assign a variable to day of the week. I just went ahead and hard-coded Monday through Friday as the input to the compare. So this compare function will pass power flow if the current day from the real-time clock is somewhere between Monday through Friday, then we're going to pass power flow, which makes sense, right? Okay, so my logic is pretty straightforward. If it's not a holiday, I check to see if it's Monday through Friday. If it is, I check to see if our time falls in between my turn on and turn off point for my lighting control. If it does, I set a coil that just says, I want the lights on because it's a weekday. All right. Similarly, I have the same logic for weekends, but this time I'm just checking to see if it's Saturday or Sunday, checking to see if we're falling between the more limited time for my weekend on and off times, and if so, setting a coil that says, yep, I want the lights on and it's the weekend. All right, now the holiday is a little bit more complicated, okay, the way I've implemented holidays, but it's pretty slick and I'm looking forward to showing it off to you. But effectively, let's start from the HMI. Okay, so I'm going to go ahead and go full screen. And let's go back to the main menu. And let's go to our set annual holidays function here. So what I've programmed into the OCS here is a really quick and easy way for a maintenance person or somebody who's with the facilities, probably a facilities person, to quickly type in or quickly enter all the holidays for the year or add one on the fly if a new holiday comes up. So for instance, what you have here on the left is you have the 12 months, and on the right you have 31 days. So I'm going to go ahead and enter in the holidays for this year. Okay, so let's start with January. January 1st is New Year's Day, and January 18th is Martin Luther King Day. So I've selected those and I hit Set Holiday. All right. The next holiday, nothing in February, nothing in March, nothing in April. In May, we have Memorial Day here in the United States. That was May 31st. I set the holiday for that. In June, there's nothing. But in July, we had Independence Day for July 4th. Okay. Nothing in August, or nothing in... Did I set that for August? I sure did. August 4th is not what I wanted. Okay, I wanted July 4th. All right. Now let's move to August, which is nothing. September, we have Labor Day. And then, of course, November, we have Thanksgiving, which is the 25th. We always get the day after as well. And then in December, we have Christmas, and usually we get Christmas Eve off as well. Okay, so what this is doing is I have basically created a control on the screen along with a little bit of logic behind it, which is setting those bits in that 32-bit double integer for each of the 12 months of the year. So I've created a variable with a dimension of 12 that's 32 bits long. Okay, and remember the way the day of the month compare works is 31 of the 32 bits within that double integer correspond to a day of the month. And I've got a different double integer for January, February, March, April, etc. So I've got a variable array with a dimension of 12 of double integers. Okay, and by setting those bits that you see on the screen, now I have the ability to use my day of the month compare to quickly determine if today happens to be a holiday or not. Okay, so let's take a quick look here and see what we've got. So I'm using this day of the month. All right, and the input for the day of the month compare function is a double integer that contains a bitmap of this month's holidays. So we are in September. The only holiday for September was Labor Day, which was the 6th. Since today is not the 6th, we're going to execute this compare. It's not going to pass PowerFlow, and so therefore Cscape will determine that today is not a holiday. Now for the days it was a holiday, that it detects are a holiday, then it's going to use the time of day compare that was configured on the start time and end time screen that we showed a few minutes ago. Okay, so this is a pretty straightforward way of creating scheduling in your OCS for determining preventative maintenance purposes, for lighting control purposes, really anything you want to use for detecting a certain time of the day, a certain day of the week, which shift is it right now, all those sorts of functions. These time of date compares are pretty useful for that. Now it's time for me to bring Casey back in. All right, Casey, so there you go with the time of date compares, which you had forgotten about. So hopefully you got something out of that today.
Yeah, it's a good refresher for sure.
Yeah, I think one thing that people don't think about as much is the bit mapping of the days of the month, for instance. Once you figure out how that works, it can be pretty useful. There's a little logic usually required to support that in terms of moving the month, let's say moving September as was stored away into the current month so you can compare it, but those are just indirect moves and those sorts of functions. So
yeah, absolutely.
Right. So that's what I did in my logic there is I had mentioned I had a integer array or double integer array of all the days of the month, and then I moved the current one over into the current month and then did the compare to see if today's a holiday. All right. So any questions on today's program at all?
I don't think so. I think we're question free today. I'll double check.
Okay,
Just one more
that's
time.
fine. While you're double checking, I will mention that if you're watching this on replay, don't hesitate to ask questions. Just type them in the comment section and we'll get those answered. Also, if you're interested in some of our demo programs that we show on these programs, feel free to email in to our tech support group or to our marketing group and just request a copy of the program. Better yet, type it into the comments and we'll probably get it maybe just as quick. By the time the email's routed to us, we probably would have answered it already. So no questions, right?
No questions.
All right, very good. Thanks for joining me, Casey, and let's go ahead and continue on. So I do want to mention every Tuesday at 2 o'clock is when we have these programs. Almost always they're live, which is why you see a glitch here and there, but that makes it exciting. One thing I do want to mention, though, coming up is for the next 5 weeks, my travel schedule is just crazy. So I'm going to be out more than I'm in. So what we're doing something slightly different. Every Tuesday at 2 o'clock, you're still going to get a new video. It just won't be a live session. So you can still ask questions. You'll just ask them in the comment section. And the new videos will be posted live on YouTube and on our website every Tuesday at 2 o'clock, just like they would if they were a live session. And they're going to be in a very familiar format, but a little bit different. So for every topic, we're going to list possible applications. We're going to describe a specific example application, show you step-by-step setup of the application in Cscape, and then show a live demo with the OCS. So it's really quite similar to what we normally do. It's just going to be a little bit shorter, a little more concise, and it won't be live. So for the next 5 weeks, that's what you will see. And here are the topics that are coming over the next 5 weeks. We're going to be covering Modbus RTU and Modbus TCP server. Very popular topic. We haven't specifically covered Modbus TCP as a server or Modbus RTU as a slave before, so we'll go through that. We're going to talk about high-speed outputs on the Horner OCS. So those are things like PWM, for instance, or high-speed position-controlled outputs. We'll be reviewing those. We'll also be using trends in the Horner OCS, doing a deep dive on trends through that new format. We're going to be talking about step-by-step, how do I use WebMI with the micro OCS specifically, because the micro OCS has some slight differences in the way that you utilize and set up WebMI. And then lastly, on the first Tuesday in November, we're going to cover some data parsing instructions. So those are some instructions that are useful for certain applications like serial port communications with barcode readers or card scanners, maybe J1939 communications. You often have a lot of data parsing that needs to be done. So those are the programs that are coming up for the next 5 weeks. And next week, as I mentioned, it won't be live, but it will be Tuesday at 2 o'clock. And that will be Modbus RTU Slave and Modbus TCP Server. So don't hesitate to subscribe if you haven't already. And once again, if you're watching this on replay, don't hesitate to ask us questions, and we'll get those answered in the comments section as quickly as we can. All right, so thanks for joining us. We look forward to seeing you next Tuesday, and everybody stay safe out there. Thank you.